of numbers in number system. Okay, so we are going to be solving some arithmetic operations that involves addition of numbers in different bases. All right, so one thing I want us to know is that, for instance, when we are adding numbers in base 10, for instance, if you have 21 plus 21, our 1 plus 1 will give us 2, right? Because we are dealing with base 10. But when it is in the binary form, our 1 plus 1 will be equal to 10. And the reason is that 1 plus 1 is 2, right? In base 10. So because when we are dealing with numbers in base 2, we are not able to write anything equal to 2 or more than 2. So we are not able to write 2, we are not able to write 3. We can only write between 1 and 0. Right? So now, if we are dealing with how we arrive at 10 and in binary form, when we add 1 plus 1, okay, you have 1 plus 1 which is equal to 2, quite all right in base 10. If you divide by 2, it will give us 2 we go into 2 once and remain what? 0. Right? So we normally, when you are adding numbers in other bases, we write down the remainder and take the whatever it was divided by the dividend, we take it to the next number. All right, so we write down the remainder. You should take note when you are adding, number bases like this. Now, if this is 10 plus 11 in base 2, if we want to add these numbers, 0 plus 1 will give us what? 1. We are able to write 1. Why? Because it is less than 2, right? But in this next place, we have 1 plus 1. It is 2. It will break the rule if we write down 2 here. That breaks the rule because there's no way we should have anything equal to 2 or above 2. So what we do is that we divide these 2 by that base, that 2. So 2 divided by 2 will be 1, remainder 0. And the rule is that we write down the remainder first. So that's why we write our 0 here first. And then if there's any number here, we add that one that we divided by to get the answer. We add it. If there is none, we bring it down. So 10 plus 1 1 in base 2 will give us 101 base 2. Same goes to other bases, like the examples we have now in base 5. If you look closely, there is no number that is equal to 5 or above 5. You can't find any 6 there, 7 there, 8 there, or 9 there. Why? Because we are dealing with number in base 5. Check here too. In base 9, there is no number here that is equal to 9. All numbers here are less than 9. So that is the rule. So we are going to be solving these examples and for further understanding. All right, so let's quickly dive into our first example here. It says 1 1 0 1 1. Okay, if you check, we have 5 digits here: 1 2 3 4 5, and this place is 4. So you should be careful in the arrangement. So we have to start from the right hand side so that it's balanced: 0 1 1. So our plus will be here. We are doing addition. Okay. So now we have 1 plus 1. Our 1 plus 1 is 2. Remember, we are in base 2. Our 1 plus 1 is 2. And I said in binary form, 1 plus 1 equals 10. That is 2 divided by 2. You have 1, remainder 0. And the rule says you should always write down the remainder first. So we're going to write down our remainder and bring our 1 here. Right? So now we have 1 plus 1, which is 2. It brings us back to this place. What do we write first? We write our remainder and bring down the 1 here. Right? So now again we have 1 plus 0 is 1, 1 plus 1 is 2, and 2 again we have our 0 here, we carry our 1 here. right? So now we have 1 plus 1, 2. 2 plus 1, 3. So we now have 3 divided by 2. 3 divided by 2 will give us 1 remainder 1. We carry our 1, right? And bring down our 1 here. 1 plus 1 is 2. We are back to this place again. And we always write the remainder and carry the 1. So therefore, our 11011 base 2 plus 1101 base 2 equals 101000 in base 2. Okay, our second example is in base 5. We have 3042 plus 2103. They are all in base 5, right? So let's add. Okay, we are always starting from the right hand side. 2 plus 3 will give us 5, right? So remember, we are not able to write out our 5. We have to 5 over 5. 5 will go into 5 once, remaining what? 0. As usual, we write down our remainder first and carry the 1 to the next. So our 0 will be here, our 1 will be here. 1 plus 4 is 5, 5 plus 0 is 5. We still have this, 5 divided by 5 will be 1 remainder 0. We write down 0, we bring down 1 here. 1 plus 0 is 1, 1 plus 1 is 2. Are we able to write down our 2? Oh yes, because it's less than 5. So we have a 3 plus 2 here, which is 5. 5 divided by 5 is 1 remainder 0. What do we write first? Our remainder. We write our remainder here, which is 0. And then our 1, because there's no other number here, we are safe to bring our 1 here. Therefore, our 3042 base 5 plus 2103 base 5 equals 10200 base 5. Okay, our third question is 3, 2, 4, 5 plus 845. You see, this is a 4-digit number and that was a 3 digits. 845 plus 1634. We add, remember, they are all in base 9. We add together. So 5 plus 5 is 10. 10 plus 4 is 14. Can we write our 14 here? No. We go the normal way. 14 divided by 9. Our 9 will go into 14 how many times? Once. And what will it remain? 5. What do we write? We write our remainder, which is 5. We bring down 1 here. 1 plus 4 is 5. 5 plus 4 is 9. 9 plus 3 is 12. So 12 divided by 9. 9 will go into 12 1 and will remain what? 3. So we write our remainder 3 and carry 1 here. 1 plus 2 is 3. 3 plus 8, 11. 11 plus 6, 17. Now we have our 17 here. How many times will 9 go into 17 once? And now what will it remain? 8. We write our 8 here and carry 1 here. 1 plus 2 is 4. 4 plus 0 is 4. 4 plus 1 is 5. Can we write our 5? Oh, yes. So now we have our answer, which is 5835 base 9. And that's our final answer. Questions on junior WAEC. Okay, so these are some of the questions in the year 2000. And the first question says we should add 1101, 11011, and 11 base 2. All right, so 1 plus 1 is 2. 2 plus 1 is 3. We cannot write our 3 because it's in base 2. So 3 divided by 2, we have 1 remainder 1. We can write down our remainder, which is 1, and carry the 1 forward. So 1 plus 1 is 2. 2 plus 1 is what? 3. Still the same thing. 1 remainder 1. We carry it forward. 1 plus 1 is 2. 2 plus 0 is 0. 2 plus 0 is 2. Right? So now we have our 2. 2 here. 2 will be 1 remainder 0. We write down as remainder, which is 0, and carry our 1 here. Our 1 plus 1 now, 2. 2 plus 1, 3. 3 plus 0 is 3. 3 divided by 2 is what? 1 remainder 1. So our 1 will be here and we'll carry our 1 forward. Our 1 plus 1 is 2. Can we write down our 2? No. We write our 0, carry our 1 forward, which will be here. Therefore, our answer is 101011. Okay, the second question says we should add these binary numbers. Okay, we have our 1 plus 1, 2, 2 plus 1, 3. Our 3 divided by 2, 3 in base 2 is 11. We'll carry our 1 forward. Our 1 plus 1 is 2. 2 plus 1, 3. 3 plus 1 is 4. Now we have 4. 4 divided by 2, it will be 2 remainder 0. We write our what? 0 here. We carry our 2 forward. So 2 plus 1 is 3. 3 plus 0 is 3. 3 plus 1 is 4. 4 divided by 2 is 2 remainder 0. We write our 0 and carry our 2 forward. 2 plus 1 is 3. 3 plus 1 is 4. 4 divided by 2 is still 2. 0 remainder 2. No. Yes, 2 remainder 0. We write down our 0, our 2 here. So remember we carry 2 here. And we can't write 2 because 2 divided by 2 is 0 remainder 1. So we write our 0 first and then our 1 will be here. So this is our answer. And then the third question, it says 1 plus 1, which is 2. 2 in base 10, in 2 in base 2 is what? 10. 1 remainder 0. We write our 0, we carry 1 here. 1 plus 1, 2. 2 plus 1, 3. 3 in base 2 is 11. So we write our 1. So 1 plus 1 is 2. 2 plus 1 is 3. We remainder 1 and we carry our 1. 1 plus 1 is 2. 2 divided by 2 is 1 remainder 0. We write our remainder first and carry our 1. So this is our answer in base 2. So if you like this video and you want more of these topics, kindly follow, like, share, and subscribe.